Hi everyone, welcome back. I wanted to make another short little video for you guys on the D and F orbitals when writing electron configurations. So it's going to be a real short video, just a few slides that I want to share with you guys and some information on how we write out those electron configurations for some of those larger atoms. So let's take a look at what we have here. So for filling the electron configurations for some of these larger atoms, it'd be nice if it was as simple as what we've already gone over with S and P block elements. Unfortunately, it's not always that easy, right? Because chemistry, that's just kind of the way it is, right? So the exceptions, there are some exceptions to what we've already learned that come into play when we are dealing with the D and F sublevels. So let's take a look at the d orbitals. So the d orbitals first appear in the quantum level 3, okay, energy level 3. However, those orbitals are not filled until elements of the fourth quantum, or elements that are in the fourth period on the periodic table. Okay, that fourth quantum level fills the d orbitals of quantum level 3. Okay. So the d quantum number is always one less, okay, that principal quantum number for d orbitals is always one less than the current quantum, or the period that that element is found in on the periodic table. Okay, our example here that we'll look at first is manganese. So manganese, if we were to write out the electron configuration for manganese, we would begin just like any other atom, 1s2, 2s2, 2p6, 3s2, 3p6, 4s, and you notice now we're in the fourth period because we're in that 4s orbital and of the s subblock. And then our d orbital, the principal quantum number is 3, even though manganese is located in the fourth period on the periodic table, okay, and 5 electrons in there. Okay, so let's take a look at this on a periodic table here. So manganese, okay, we determined 5, so it'll be here. This fourth period, okay, is where our D sublevel block begins. If we take a look at the F sublevel block here on the very bottom, okay, we'll get to that. It's a little bit different also. That one begins in the fourth principal quantum number. So we would normally think that those sublevel blocks for D are going to be in the third period. However, that's the one of the exceptions to the rule there. Okay, it is always one less. Okay, so let's take a look at those F orbitals then. So F orbitals always appear in quantum level 4. Okay, that's where they first appear. However, they're not filled until elements of the 6th quantum. Now, those F orbital block elements are those elements that are usually found in those 2 rows or 2 periods at the very bottom of the periodic table. And they're put down there because if we were to fit them in where they normally would belong, we'd have this really, really wide, long periodic table. So less efficient to set it up that way on a wall or something like that. So those F orbitals are not filled until elements of the 6th quantum. So you would be filling 6s and then move into 4f orbitals. So the F quantum number always 2 numbers less than the current quantum number, or the period that that element is located in. Okay, so 6th quantum level fills F orbitals of the 4th quantum. Okay, so if we look at promethium, okay, and we write out the electron configuration for promethium, okay, we get to 4s2, okay, 4s2 here, and then we get to the d orbital, it's 1 less. Okay, when we get to the 5th period and the 5s orbital, okay, again, another d orbital, it is also 1 less. Okay, if we keep going, we get to the 6th period, okay, and we reach our very first f orbital, but it is 2 numbers less, so 4f for that particular orbital. And those are the 2 exceptions to the rule, okay, to how we write out that electron configuration for the elements that have those orbitals in them, okay? So as we write them out, and again, you don't have to memorize this, right? If you can read the periodic table and you remember how to do that, you don't have to memorize this. So 1s, 2s, 2p, 3s, 3p, 4s, 3d, okay, that's our first d orbital, it's 1 less, 4p, 5s, 4d, okay, again, 1 less for that d orbital, okay, and as we move down those all increase in energy, okay, that's one thing you might want to write down, is that those increase in energy as we follow those down. And continuing on to 5p, 6s, 4f, okay, 4f there, 2 less, even though it came after 6s and is in the 6th period. Okay, 5d, 6p, 7s, 5f, 6d, 7p, and again, continuing to increase in energy. So I hope this helps you with that exception for the D and F orbital electrons, and I will see you guys in the next video. Thanks.